Hi everyone, it's Mr. Hirsch, and today we are going to talk about constructing arithmetic sequences. Okay, so our question today is, what is an arithmetic sequence? And we're going to explore a little bit and then we're going to come back to that question. So let's look at the exploration. Here is the situation. You are ordering tickets for a local online theater. You are going to get charged $2 per order. That means if you order one ticket, you're going to pay a $2 fee. If you're going to order 10 tickets, it's just a $2 fee. You're going to the matinee with some friends. That's the daytime event. And they cost $10 each. So the total cost in dollars of ordering N matinee tickets, that means any number N, whole numbers, online can be found by using C for the cost of N equals 10 times N plus 2. Let's look at the table and fill it out for if you bought between 1 and 4 tickets. So if you bought one ticket, it would cost $10 times 1, here N equals 1, because tickets, this is the N, right? Plus $2. 10 times 1 is 10 plus 2 is 12. If we bought 2 tickets, that's going to be 10 times 2, which is 20, plus 2 is going to be 22. If you bought 3 tickets, 10 times 3 is 30, plus 2 is 32. And then if you bought 4 tickets, I'm guessing you're seeing the pattern. It's 10 times 4, which is 40, plus 2 is 42. So looking here, we want to know what is the domain of this sequence. The domain, right, that's like the X value, the N, is the number of tickets. So the domain of this is going to be 1, 2, 3, 4. In real life, this could be more, so we're going to go like that. That's the domain of this sequence. What is the range of this sequence? So this is the total cost. They're asking how much. So this is going to be 12, 22, 32, 42. And what do you think? If they kept buying tickets, it's going to go up, right? Now we're going to ask, what is the first term of this sequence? Well, the first term here is under the 1. That's going to be 12. Now, when we are looking at arithmetic sequences, we want to know what the difference is between consecutive terms. Consecutive means in order, right? They come next to each other. So in this case, 12 and 22 are consecutive. 22 and 32 are consecutive. They come in order. 32 and 42 are consecutive. So the difference means subtraction. So we're going to find the difference here. That's going to be 22 minus 12 is 10. 32 minus 22 is 10. 42 minus 32 is 10. What do you notice about those differences between consecutive terms? So let's ask a question. Suppose you extended the table for up to 15 tickets. Would you expect the difference between consecutive terms to be the same? Why don't you pause the video and answer for yourself? Great. Let's see. So we are in an arithmetic sequence, right? And in an arithmetic sequence, the difference between consecutive terms is the same. So what did you say here? Yes, comma, because as we move to the next term, we always go up by 10, right? So that's one of your clues, right? Look at the difference is always the same. what's our pattern here? Up by 10. Start with the first term, go up by 10. Okay, so how is the domain limited in this situation? So let's go back and look at the domain. How is the domain limited? So our domain is limited because it is always going to be what? It is always going to be a whole number, right? Our domain's never going to be a half. It's never going to be a third. Doesn't matter if you're talking decimals or fractions, your domain is always going to be that whole number. So I'm not going to write that in, but you should. If you were doing this, that's what you would do. Okay. Ready to move on? Good. So let's move on. In an arithmetic sequence, the difference between consecutive terms, terms in order, is always equal. That's the rule for an arithmetic sequence. The difference, written as a lowercase d, is called the common difference. It's common because it's always the same. So in an arithmetic sequence, you can describe it in two ways, both explicitly and recursively, right? We learned these last week. As you saw earlier, in an explicit rule for a sequence, the nth term, any term n, of the sequence is defined by the function of n. In a recursive rule for a sequence, the first term is given and the nth term is defined by relating it to a previous term. So you can define an arithmetic sequence using either a recursive rule or an explicit rule. And what we're going to do today is we're going to practice and learn how to do both. Okay, so let's look at an example here. We're going to write a recursive rule and an explicit rule for the sequence described by each table. The table shows a monthly balance in a savings account with regular deposits. The savings account begins with $2,000 and $500 is deposited, that means put in, each month. So let's look. Time in months is n, 1, 2, 3, 4, 5 months. The balance, or f of n, is 2,000 to begin with, and then goes up by 500 each month. So we want to write a recursive rule. So first of all, we need to know that f of 1 is 2,000 because that's defined right here and where it says begins with 2,000. So f of 1 equals 2,000. And the common difference, right, if f of 2 minus f of 1 is 500. f of 3 minus f of 2 is 500. That's the common difference, is 500. So the recursive rule is f of 1 equals 2,000. Remember, in a recursive rule, you always give the first one. And f of n, for any number greater than 1, greater than or equal to 2, equals f of n minus 1, the previous term, plus the difference, 500. Okay, here's our recursive rule. So to write an explicit rule, we want to say we have to talk about it in terms of f of n, not f of n minus 1, not the previous term. So let's look. F of n here for the first one is 2,000, right? And what is it going to equal? It's going to equal, this rule is a given. F of 1, it's going to equal your start point plus the difference times, this says x, it really should say n, times n, okay, the difference times n. So f of n equals f of 1 plus the difference times n. Which spot in the term is it? So on the first one, f of 1 is 2,000. The difference is 500. N is, oh, that's why it's not an n, it's an x. X is 0, okay, because that's going to be 0 in this case. Where's our x on our, that's what they mean. Sometimes Mr. Hirsch gets confused, right? X is 0. So on the axis, you would be on the axis here. So 500 times 0 is 2,000. In this case, x equals n minus 1. Okay, and we'll show you that in a minute. Okay, the second one is f of n is going to be 2,500 because we know they go up by 500. It's going to be f of 1 or 2,000 plus 500 times 1, which is 2,500. And the third one is 2,000 plus 500 times 2, which is 1,000 equals 3,000. Since d is always multiplied by a number equal to n minus 1, x equals n minus 1. We can make a generalization of the result from the table. The explicit rule is f of n equals 2,000. That's going to be f of 1, but it's always going to be the same, plus 500 times n minus 1. Okay? So if n is 1, n minus 1 is 0. If n is 2, n minus 1 is 1. Okay? So here's the table showing the monthly balance in your savings account with regular monthly deposits. Here's the time, here's the balance, okay? To write, this is a new one. Can you fill this out? Pause your video, give it a try. Great. Here, we're gonna write the recursive rule. F of 1 equals, what does f of 1 equal? Here's n equals 1. F of 1 equals 5,000. And the common difference, what's the difference between 2 and 1? 6,000 minus 5,000 is 1,000. So the recursive rule equals f of 1 is f of 1 equals 5,000. And f of n equals f of n minus 1 plus the difference, which is 1,000, for all values where n is greater than or equal to 2. Okay, so here it is filled out with the d times x function rule. F of n for 1 is 5,000. That's 5,000 plus 0. Here we're going to say 5,000 plus 1,000 times 1, which equals 6,000. Then we're going to say 5,000 plus 1,000 times 2, which equals 7,000. Oops, I wrote that wrong. Since d is always multiplied by a number equal to, do you remember what this was up top? N minus 1. We can generalize the result from the table. F of n equals 5,000 plus 1,000 times n minus 1, because you're always multiplying it by a number 1 less than the n. Here the n is 2, you multiply it by 1. Here the n is 3, you multiply it by 2. Okay. So here's some reasoning. Read this for a moment. So if Jerome says the sequence is 1, 8, 27, 64, 125, is it and he says it's not an arithmetic sequence, is that correct? Well, how can we tell? Remember, an arithmetic sequence must have a common difference, right? Let's check. 8 minus 1 is 7. 27 minus 8 is 19. Is that a common difference? No. So is Jerome correct? Yes. Because the sequence does not have a common difference. All right, let's read the next one. An arithmetic sequence has a common difference of 3. If you know that the third term is 15, how can you find the fourth term? Well, if the difference is 3, that means that the fourth term is 3 more than the third term. So we are going to add 3 to 15 to get the fourth term, which would be 18. All right, so here's your turn. The table shows a number of plates left at a buffet after n hours. Write a recursive rule and an explicit rule for the arithmetic sequence represented by the table. Okay, so you're going to try this on Edpuzzle now. Write the recursive rule. Write the explicit rule. Were you able to do this? So the recursive rule, first we need to know f of 1 equals 155, and the common difference so this is going to be 141 minus 155. Notice it's getting smaller, so the common difference is going to be a negative number. Let's see, 155 minus 141. That's 14, so it's negative 14. If f of 1 is 155 and the common difference is negative 14, then the recursive rule is f of 1 equals 155, right? What else? And f of n equals f of n minus 1, or the previous term, plus the common difference, which is minus 14, right? So that's our recursive rule. F of n minus 1 minus 14 for all numbers, or for all n's greater than 1. So what's the explicit rule? Well, the explicit rule is going to be not in terms of f of n minus 1, right? It's not about the previous term. It's about n. But it kind of is also, because you need to subtract 1 from n. So in this case, f of n is going to equal how much? What are we doing? Where do we start? Well, we start with f of 1, which is 155. And then we subtract n minus 1 times 14, or 14 times n minus 1, because that's the difference, right? So 14 times 2 minus 1 would be 14. 155 minus 14, right? Then we get 155 minus 2 sets of 14s, because n minus 1 when n is 3 would be 2, etc., etc. So when you're looking at this for the explicit rule, f of n equals your starting number, right? Whatever f of 1 is, minus the common difference times 1 less than your n. Okay? In this case, that's going to be, in the second term, is going to be 1. 2 minus 1 is 1. Does that make sense? I know it's a little bit confusing, but you're going to get there. All right, let's look at example 2. In this one, explain 2. We're gonna use a general form to construct rules for arithmetic sequences. So we worked it out there. Now let's learn the general form. So arithmetic sequences can be described by a set of general rules. Values can be substituted into these rules to find your recursive and explicit rules for a given sequence. Your general recursive rule, given f of 1, f of n equals f of n minus 1 plus d for all numbers where n is greater than or equal to 2, right? The general explicit rule is f of n equals f of 1 plus d, the difference, times the number n minus 1. Okay? So we're going to practice writing recursive and general explicit rules for each arithmetic sequence. All right, let's look at the example. Here's a sequence that's arithmetic. We can check by doing the differences. F of 1 equals 100. The common difference equals 88 minus 100, or negative 12, because 100 is 12 more than 88. So the difference is a negative 12. The recursive rule is, looking at the general, f of 1 equals 100, f of n equals f of n minus 1 minus 12, because that's the difference for n is greater than or equal to 2. The only things that are different here from the general up here is we put in the number 100 for the start value, and we put in minus 12 for the common difference. The explicit rule, looking up here, f of n equals 100, that's the f of 1 value, minus 12 times n minus 1, right? Once again, we put the minus 12 in, we put the 100 in. All right, let's see if we can do it for letter B. I'm going to pause the video so you can fill this out. Good. So let's see. F of 1 equals what? It equals 0 because our start value is 0. What's the common difference? So this is going to be their second term minus the first term. 8 minus 0, which equals 8. Oops. So the recursive rule is going to be f of 1 equals 0. F of n equals f of n minus 1 plus 8, for n is greater than or equal to 2. The explicit rule, f of n equals 0, the start value, plus 8 times n minus 1. All right, does that make sense? Let's look and see and reflect. What is the recursive rule for the sequence f of n equals 2 plus negative 3 times n minus 1? All right, this here, is this a recursive rule? This is the explicit rule. So can you look at this and see? Well, what's this? This is going to be f of 1, also known as our start value, right? What is this? This is going to be the common difference. So what is it going to be, and how do we know? Well, the recursive rule for this one is going to be f of 1 equals 2, right? We always got to start with that. F of 1, identify f of 1 equals 2, right? And f of n equals f of n minus 1. You could say plus a negative 3 or just minus 3. How do we know? We know because the general rule tells us from the explicit formula that f of 1 is 2 and d is negative 3, right? Let's make it magically appear. Isn't that great? Look at it magically appearing. All right, can you write a recursive rule and explicit rule for the arithmetic sequence? Well, what's the common difference? Equals 10. What's f of 1? Equals 6. So, recursive. F of 1 equals 6, right? F of n minus 1, f of n equals f of n minus 1 plus 10 for n is greater than or equal to 2. For all values where n is greater than or equal to 2. What's the explicit rule? Well, the explicit rule tells us f of n equals the start value, or the f of 1, 6, plus 10 times n minus 1. Right? Right. You got this. You are a rock star. Oh, wait, what did we, oh, no, that's good, right? We could say that f of n equals 10 times n minus 1 plus 6. But we could do it this way too. Actually, correct is going to always have your constant at the end. So we probably want to do it this way for correct notation. All right, let's look now at the third explained, relating arithmetic sequences and functions. The explicit rule for an arithmetic sequence can be expressed as a function. You can use this graph, the graph of the function, to write an explicit rule. All right, so let's look at example 3. Write an explicit rule in function notation for each arithmetic sequence. Now, looking at a graph, you can tell if this is an arithmetic sequence if your points are in a line and they are equally spaced. In this case, you can look at this and say that's an arithmetic sequence because the difference is always going to be the same between 1, 2, 3, and 4, right? So let's look. What is this showing? The cost of whitewater rafting trip depends on the number of passengers. The base fee is 50, and the cost per passenger is 25. The graph shows the sequence, right? Let's look at the graph. If you have 1 passenger, you pay 75, 2 is 100, 3 is 125, 4 is 50. 150. Notice the n is the x value, f of n is the y value because n is the domain, the number of passengers. F of n, y is the range or the cost. So let's look at this. You can represent it in a graph, you can represent it in a table. 1 is $75, 2 is 100, etc. So step 1 is represent the sequence in a table. When you are given a graph, let's put it in a table. Number of passengers and cost. 1, 2, 3, or 4, 75, 100, 125, 150. Step 2, find the common difference, right? 100 minus 75, 25, 25, 25. The common difference, D, is 25. Step 3, then, you now have the start value, the f of 1, and you have the D, the difference. Write it out. F of n equals, right? You're going to substitute 75 for f of 1 and 25 for D. F of 1 plus D times n minus 1. That's the general. That's the general rule, right? For the explicit. F of n equals 75 plus 25 times n minus 1. That's the actual. So, when looking at this, let's try again. The number of seats per row in an auditorium depends on which row it is. The first row has 6 seats, the second row 9, etc. Looking at our graph, we see these are equally spaced in a line. So if the row is 1, how many seats? 6. 2 is 9, 3 is 12, 4 is 15. Let's find the difference. F of 2 is 9 minus f of 1 is 6, that's 3. F of 3 is 12 minus f of 2 is 9, that's 3. F of 4 is 15 minus f of 3 is 12, that's 3. The common difference is 3. Let's write the explicit rule. Now we know what f of 1 is. Substitute 6 for f of 1 and 3 for D. So f of n equals f of 1, or 6, plus D, or 3, times n minus 1. There we go. So let's look at this question. Analyze relationships. Compare the graph of the function f of x equals 3 plus 5 times the quantity x minus 1, and the graph of the sequence. So this one is y equals 3 plus 5 times x minus 1, which could end up being, right, because f of x equals y. Right, this is a linear equation, equals 3 plus 5x plus, or minus, let's fix that, minus 5, or y equals 5x minus 2. We could graph that. Y equals 5x minus 2, right? The y equals mx plus b tells us that minus 2 is going to be the y-intercept, and it goes up 5, the slope 1, 2, 3, 4, 5 over 1, up 5 over 1, right? This is going to be a line like this. So notice, what's the graph of the function is a line. The graph of the sequence here, n, this is discrete. N has to be a whole number because it's a sequence. So n is going to be 1, 2, 3, 4, 5. So if we look here, right, I'm going to show this in red. When n is 1, it's going to be here. When n is 2, it's going to be here. When n is 3, it's going to be here. It's dots along the line. So what is the relationship? The graph of the function is a line, and the graph of the sequence is dots on the line. Let's make that magically appear. How about that magic? All right, let's look at the next one, your turn. Jerry collects hats. The total number of hats in his collection depends on how many years he has been collecting hats. After the first year, Jerry had 10 hats. Each year, he's added the same number of hats to his collection. The graph shows the sequence. All right, so first thing we are going to do here, we are going to make a chart. We have n, and we have f of n, right? So when n is 1, f of n is 10. When n is 2, f of n is 18. You don't have to write it like a chart. You could write it out horizontally. When f is 3, f of n is 26. When n is 4, f of n is 34. So what do we do now? We want to find the common difference, right? Because this here, n, is time in years, and this is number of hats, right? So what's the common difference? 18 minus 10 is 8. 26 minus 18 is 8. 34 minus 26 is 8. D equals 8. So let's write this out. F of n equals f of 1, 10, plus 8, the difference, times n minus 1. Correct? That's the explicit rule in arithmetic sequence of this problem. Okay? So at this point, you should understand enough that you could go on and do the homework. Oh, wait, let's elaborate because we've got a couple more to do here. Can you answer these questions? You should read these over because I'm going to ask you to answer these questions when we get to class. Okay, so let's read them. See if you can figure it out. What information do you need to write a recursive rule for an arithmetic sequence that you do not need to write an explicit rule? So think about the difference. What information do you need to write a recursive rule that you don't need to write an explicit rule? Also, suppose you want to be able to determine the 90th term in a sequence, that's 90, in an arithmetic sequence, and you have both an explicit and recursive rule. Which rule would you use? You can use the recursive rule or the explicit rule and explain why. Okay? Finally, the explicit or the essential question check-in. The explicit equation for an arithmetic sequence and a linear equation have a similar form. How is the value of m in the linear equation y equals mx plus b similar to the value of d in the explicit equation of f of n equals f of 1 plus d times n minus 1? Think about these, find your answers, because I am going to ask them when you get to class. Thanks so much for watching. I really appreciate you taking the time. Have a great day. I'll see you tomorrow.